All right, we're going to look at creating sinusoidal functions from data. And we have two major ways to draw a sinusoidal function. Actually, three. You could technically include a tan function. But we're going to focus on cos and or sine. And for this example, we'll specifically look at cos. They've given us these parameters to draw a Ferris wheel. And then we're going to try to draw the equation of it and see if it kind of matches our rough sketch. So they said the Ferris wheel has a radius of 8 meters. The bottom of the wheel is a meter above the ground, and the wheel rotates every 12 seconds. So it's usually pretty helpful if we can just create that same idea in a picture, because sometimes I find at least that helps me make sense of everything that's going on. So I'm going to ask you to try to help me out here. How high is the bottom part of this Ferris wheel? So the lowest to the ground. How high above the ground, I should say, is it? What is the distance here?
1 meter.
Yeah, perfect. Okay. They said the radius of this object is how many?
8 meters.
Perfect, 8 meters. Which means the center, and I'm going to draw a horizontal line red here. So the center of this object is how many meters off the ground?
9 meters.
Perfect. Okay, that's really important for us because that's going to help us make sense of something a little later on. I think that's all the info they give us. I don't know if I wrote it down, but they want us to start our rotation 9 meters above the ground, which means, so at the center actually, which means we could be starting here, or we could technically be starting here. It's really our choice. Where would you like to start? Would you like to start at the left side and go down? So let's assume that we're always going to rotate counterclockwise on this wheel. Would you like to start here, or would you like to start here? Right or left?
Doesn't matter.
Doesn't matter? Okay, let's just start on the right then. Okay, so let's assume we are starting here. So as time passes, we're at 0 seconds and 9. And an entire rotation, they told us, so the wheel rotates every 12 seconds. An entire rotation, we would be at 12 seconds, that would be our x, and 9 again. So that's when we get all the way around and back. So if I'm not sure how to break that into quarters, I can continuously halve stuff. I know that I'm going to be halfway through the ride when I'm at the other side of the Ferris wheel. My y value will still be 9. My x value will be halfway between my 0 and my 12. So that means it'll take me 6 seconds to get there. And then, again, to get to the top, well, that's halfway between these 2 points. The top, now we'll have to use the radius to help us figure this out. Since the center is at 9 and the radius is 8, how high up will we be at the very top? Do you know?
17.
Perfect. 17 meters. And what would be halfway between 6 and 0? How much time will have passed?
3 seconds.
Excellent. And then finally, this one here, we've already talked about how high it will be. We know we'll be 1 meter off of the ground. What will our time frame be? Be halfway between 6 and 12.
9.
Excellent. Great. So this can really help us when we're going to draw our rough sketch. So I'll kind of draw a rough sketch of what's happening just here. Okay. Because we're going to use it we're going to draw it as a sinusoidal function. We said we're going to start in the middle. So let's say that's the middle and that's the point of 9. Here's our 1 and here's our 17. Now obviously this is a terrible scale, but I just drew our major points just so we can get the gist of the idea. We also know that our x values are, we can say maybe going up by 3s. That might be helpful. So if this is 0, this will be 3, 6, 9, and 12. And that's an entire period for what we need to do. So we knew at 0, 9 is our starting point. At 3 seconds, we're at 17, so that's way up here. At 6 seconds, we're back at 9. At 9 seconds, we're all the way down to 1. And then at 12 seconds, again, we're at 9 again. Okay, so we've done this type of rotation. Okay, so we have this function that represents our Ferris wheel. Now, what we need to do is we need to turn it into a cos function. Okay, so the first thing we need to find is the equation of the axis. Do you know a formula that would help us find the equation of the axis?
Max plus min over 2.
Perfect. Yeah, max plus min divided by 2. So what is our max and our min in this case?
17 and 1.
Perfect. Okay, so 17 plus 1 over 2 is 18 over 2, which is 9. That's exactly what we drew, right? That's our equation of our axis. How about the amplitude? Do you know a formula for the amplitude?
Max minus min over 2.
It's min over 2. okay, which leaves us with those same values before, 17 minus 1 over 2, which gives us a value of 8. Great. So the amplitude is actually our a function. You can almost think of a representing amplitude. So we already know that our a value is going to be 8 in this case. The equation of the axis is essentially where our c value is going to be. So if that's positive 9, that means our c value is going to be the value of 9. Now our period normally equals 2 pi, right? And in this case, our period happens to be 12 seconds. So the way we find out what our period is going to be, let me think of a great way to explain this. Okay, so let's say a formula for k is our normal period, okay, which we've already written out here to be 2 pi. We'll say normal p, divided by our new period. P will represent our period. Okay, so in this case, k is equal to our normal period being 2 pi divided by our new period, which is 12. Okay, which then means k is equal to pi over 6. There we go. Great. So we've set up a lot of our info. The only thing left is our d. Now our d is going to vary depending on whether we're using our sine or our cos, because the sine and cos are roughly the same thing. They just have a phase shift horizontally. What we need to happen is we need ours to phase shift. So let's plug these values in into our graph. What we already have here. We have a cos, okay? And we said that our k value was going to be pi over 6, pi divided by 6. Okay, we said our c value was going to be positive 9, and we said our a value was going to be 8. Okay, so when we go take a look, this is excellent. The only problem here is this looks great. We have our peak being 17, our trough being 1. Our entire period took 12 seconds. The only thing is we want ours to start at the point of 9. Okay, so we kind of need to figure out how far to shift our function over. Okay, so in order for our function to shift, we need the equation of the axis. And we said our equation of the axis was that x is equal to, y is equal to 9. Right? There's our line kind of running through it. So we need this point here to either be back, so we either need to shift backwards, or we need this point here to shift forwards. And these coordinates essentially tell us how far left or right we need to go. And that's where the idea comes from. Do we want to go up first? When I was talking about do we want to go up first, or do we want to go start from here and go down first? If we were to shift back 3 units, okay, so if I shift back 3 units, let's say we go plus it to 3. If we do that, then it goes down first. And that wasn't quite the Ferris wheel we had shown, right? So I'm going to get rid of that 3. And this is where our cos function happens. We want this to actually shift to our left. So because we want to shift to the left, we are going to add. Whoops, that's what I did. Sorry. Minus 3. There we go. And now we're essentially heading upwards, coming back down, and heading upwards again. How do we use a sine function? If we look down here, we have our sine function. We wouldn't have to use a phase shift, and you'll see it just overlapped exactly what we had before. We wouldn't have to use that phase shift because a sine function essentially starts right in the middle, and that's what the question was asking us. So if you kind of want to see what the Ferris wheel ride would look like, copy this, our function, paste it in here. We'll say x1. Okay, so if we're starting at 0, we head up, and at 3 seconds we hit the top. At 6 seconds we're back in the middle. 9 seconds we're back at the bottom. And then at 12 we've completed the entire period of the function. So that's what our Ferris wheel ride essentially looks like. Okay, so in terms of writing our equation though, and make sure I gotta write it out here at the bottom, our function is equal to, we said our a value was 8, equals cos. Our k value was pi over 6. Okay, we need it outside of the brackets. We made our our d value we said was minus 3. I believe we wrote minus 3. And then our c value was plus 9. So there's our equation in the end. For d is by taking one of the coordinates that we know, which is 0, 9, okay, and we have our equation down here. And we can actually plug that coordinate in, 0, 9, represent the x and the y, and then we could isolate for an unknown d value. Since we had all of the other, we had our a, our k, and our c value. So we'll replace x with 0 and y with 9, so f at x is now 9 is equal to 8 cos pi over 6. This becomes 0, so it's essentially negative d. Plus 9, okay. First bed mask kind of thing, so we'll take our positive 9 and we move it to the other side, it'll become negative 9. So we'll get 0 is equal to 8 cos pi over 6, negative d. Okay, next, because this is 8 times cos, when we bring it over, we divide by 8, and 0 divided by 8 is still 0. So 0 cos pi over 6 minus d. Okay, and in this case, we get cos 0. So if you look at cos 0 is 90. I'm going to kind of show it here, or the cos inverse of 0. My calculator, here it is. If I do second function cos of 0, it gives us, and this is our radians. And in radians, we know that 90 degrees is pi over 2. So if I were to go pi divided by 2, lo and behold, we get the exact same answer. So it didn't show it in radians, but that's what it's showing. So we're going to use it to pi over 2. When we do essentially we're bringing cos over, so we do the cos inverse of 0, we get pi over 2, which is then equal to pi over 6 times negative d. Okay, we can move this by almost by like cross multiplying. Okay, this over, and this kind of comes to the bottom. So this becomes, the pi's would cancel out, and you'd have 6 over 2, so this is 3. Okay, if you're unsure to do that, you can just double check that, which is d is negative. So in this case, we have d is equal to negative 3. So when we want to put negative 3 into the equation, because it's minus d, so the concept kind of goes like this. You get f at x is equal to, our a value is 8, cos, our k value is pi over 6, and then it becomes x minus negative 3, okay, plus 9, so I should draw that in green, minus negative 3, and when you subtract a negative value, it's the same as adding, and that's how we would get our plus 3 that we did before when we looked at the graph there.